Hello, this video is for anyone that needs to make corrections to their metabolism quiz. If you go to your classwork folder and go to test corrections, you'll see W8D1 Metabolism Quiz Corrections. If you click on this document, it asks you simply to correct two possible questions. You could correct more. The two most commonly missed questions I'll show you right now. By looking at fourth hour quiz, and this is probably the same also as it would be for the other 2 hours, the frequently most missed question is the last two questions, which regarding the sulfur questions, and also some people miss the questions regarding the breakdown of molecules. So let me show you those. Identify where nutrient macromolecules chemically break down in the body. Some macromolecules may break down in more than one area. We had quite a few people that got these incorrect, so only 10 out of 17, and the other classes were lower. So one of the things we have to look back at is you originally did see a slide that looks something like this. And let me play this for you. And as we can see here, this slide shows you a little bit about what's going on with the digestion of molecules. One of the things to look at is we have some terms that all have a common feature to them. And let me get my pen pulled up, and we'll show you what those are. We have salivary amylase, pepsin, trypsin, chymotrypsin, and carboxypeptidase. More peptidases down here. And over here we have disaccharidases and pancreatic amylase. And the key thing is a lot of these terms end in ASE. You can see that it's a common thing. What all these things are they are considered to be what are called enzymes. And enzymes are protein molecules that are designed to break down things and turn things into smaller substances. A lot of times I like to use a Pac-Man symbol to represent an enzyme. So we have there's your Pac-Man. And so if we get a large macromolecule to come into this particular enzyme, so something like a protein or a polypeptide, which is a large item here. So if we were to take this polypeptide and we were to bring it into this enzyme, and let's say it was pepsin or peptidase or something like that, that polypeptide would then be broken down into the monomers, which are known as amino acids. And most of us understand that. So we can break down that long chain molecule into something smaller. Well, anywhere you see an enzyme on this page indicates where the nutrient is breaking down. So you can see that the mouth for carbohydrates, and I'll put a box for carbohydrates, start to break down in the mouth because there's salivary amylase. So that's where carbs can break down. I don't see any sort of enzymes in the stomach that break down carbs. Nothing is attached there. So I'll leave that alone. We get down to the duodenum, which is part of the small intestine, just the upper part. And then the rest of the small intestine, which is the other part. And we can see there's plenty of carbohydrate or disaccharide aces or different enzymes that break those things down. So I'm going to put a square around these two so we can see that. So for carbohydrates, all three areas are where except you do not have any breakdown because remember, these two are the same. These are both the SI, the small intestine. So both of those are the small intestine. So really I should just put a big box around that. There we go. So that's all small intestine. As you can see then, you only have two areas where carbohydrates break down, in the mouth and in the small intestine. And you can use either of these enzymes to help justify that when you correct your quiz. We go over to lipids, and let's use circles for that. If I use a circle here, I see no breakdown in lipids in the mouth, none in the stomach, and then we start to see in the small intestine, some more breakdown in that. So the small intestine, again, we would see some lipids breaking down. And it has to break down somewhere. So your lipids are going to be breaking down in the small intestine. So they're breaking down into your fatty acids and glycerol. And again, this is the SI, the small intestine. So only one area there. And you can use pancreas or bile salts from the liver to justify that. Let's go to proteins. All right, where are proteins breaking down? And we'll use a triangle for that. So we have a triangle here. Where are proteins breaking down? There's no breakdown in the mouth, but there's definitely some breakdown in the stomach. So protein starts to break down in the stomach. So we can put a triangle there. And then obviously in the small intestine, everything breaks down in there. So we can have that large triangle here of in the small intestine. Those break down, gives you some pepsidases and things like that. So when you're answering that question that a lot of people missed, you can utilize this information here to help you with that. Make sure you include enzymes and where the nutrients are breaking down in your answer if you're fixing that one. The other question is more so related to the asparagus, and I'm going to use my bill for that. And this is a fairly detailed explanation of what's going on with the asparagus. So first off, we know that asparagus contains sulfur compounds. And these sulfur compounds, as we saw in the article, could be long chain molecules of sulfur that are within them. Not sure why asparagus contains these things, but we know that plants contain different chemicals for different reasons. Some plants contain harmful poisons to prevent animals from eating them. Other plants produce substances to encourage consumption so that seeds can be spread. I'm not sure why there's so many of these sulfur compounds in asparagus. We might have to look at that in a future time. But anyway, when we take these, we know that if we go through the process of digestion and we go through the process of absorption, these particular molecules are going to break down into smaller molecules. So they're going to be breaking down into smaller substances, and they're not going to be the large macromolecules that you won't see. And then we saw that in the article too. We saw that the sulfur is made up of these smaller compounds. Well, now if you've gone from the food, the asparagus, now you're in the bloodstream. You're in the blood. So we have these molecules in the blood because we digested the asparagus, which also has carbs. So remember, the carbs had to, we want to get energy out of it. So, you might have gotten some glucose. And we know what we would use glucose for. We would use it for energy. Well, what about these things here? What about these sulfur things? What are we going to use those for? That's the question. Well, here's some choices. Could we use them for one of a couple different things? First one, well, we know that if we take molecules in and we break them into monomers, because remember, we're in our monomer section over here. If we have monomers, we could build new things. So we could take this sulfur and we could make them into maybe new cells or new molecules and things like that. Could we build new stuff? So I'll put new stuff. Is that a possibility? So that would be biosynthesis. Well, I can't really think of anything that we would build that contains a lot of sulfur. I don't smell like a rotten egg. And I know that my friends don't. So I'm highly, especially after eating asparagus, it's not like we change into an asparagus plant. So I really don't think biosynthesis works. I don't think we're really going to get anything out of these sulfur compounds. Well, the next thing, could we go through cellular respiration, which we'll abbreviate CR? We know that through cellular respiration, we get energy. Well, there are some creatures on Earth that get a lot of energy out of sulfur, but they live miles deep in the ocean, near deep ocean vents. And I don't think I see too many. I don't live near a deep ocean vent. I don't suck in sulfur. So I don't think I'm going to really use this sulfur for any sort of cellular respiration type of process or anything that would provide me with energy. So I'm scratching that off. So what do we do with these things? Do we let them float around in our blood for the rest of our life and just sit there? No, we can't do that because obviously they take up space and they're not really serving any sort of purpose. And if you're a molecule that's in your blood and you're not serving any sort of purpose, guess what happens to you? You get excreted. So excretion is what's going to take place. Now, excretion could utilize a couple different places. We could be excreted through sweat. We could be excreted through our breathing, our breath. Or we could excrete things out, our urine. We have a couple different choices. Well, after I eat asparagus, sometimes I have some bad breath, I'm sure, but I don't really go out and notice that my breath smells like rotten eggs, or I have this weird, smell coming out of my breath. So I don't think it's coming out of my breath. Well, a lot of times I work out, and I've had asparagus and I've worked out, and it's not like my sweat. I didn't stink or smell funky after I consumed asparagus. So I highly doubt that those molecules are going to go out through sweat. Which leaves us to what the article hints on, that, yeah, these same little monomers, these sulfur monomers, are going to be in the urine. And that's what makes the urine smell funny. So those monomers are now in the urine. And how did they get to the urine? Well, they came out of the blood. And you have an organ which will take those things, taking those little sulfur molecules, and you have what is called a kidney. And that kidney is what processes and makes urine. And it is able to take low concentrated stuff. So like this is low. And it's able to make highly concentrated material. So it takes up a bunch of like diluted stuff and can make a very concentrated solution. Now that the kidney does need energy to do that. So it would use energy from glucose and other places. So it's an important thing. But that's kind of the story here. And we have to keep in mind that, yes, so the molecules, even though they got chopped up into monomers, we didn't really use them for anything, but they're small enough to be filtered out by the blood and the kidney and put into the urine. So there you go. That should help you with explaining why they are monomers or what happens to these particular things and why they're in urine. I hope this helps you. Go ahead and fix that quiz and you can submit your corrections. And if you have other questions, feel free to ask me in a chat during class, or anytime you get a chance, you can ask questions about those and you can get your points back. All right, good luck.